everyone, welcome back. Now that we understand better the kinetic molecular theory of gases and we can relate that to how that affects pressure, volume, temperature, and the amount, let's put that into formulas. So on this part of the lecture, we are going to start studying different laws that governs the behavior of gases, and they come with formulas. So we're gonna talk about the Boyle's law. We are also going to talk about the charge law. The Boyle's law, let me just show you the formula right now, looks like this. P1 B1 equals P2 B2. And what this law allows us to do is to, given a before situation, if I change one of the variables, what will be the after situation? For example, if my pressure is some amount, and I take the volume and make it smaller, according to the molecular theory of gases, since the volume is smaller, the particles will hit the walls of the container sooner, which means they're going to have more force because they haven't traveled too much. So that means that the pressure should go up. So that's what that law is going to tell us. It's going to allow us to see numerically what the kinetic molecular theory of gases is telling us that it will happen. So the Boyle's law is the only law where one property is inversely proportional to the other. So for example, if the volume goes down, the pressure will go up. So inversely proportional. Or the other laws that we are going to study are directly proportional. Like for example, the charge law. Charge law looks like this. Which is the same as this. So in terms of comparison, to be able to see before and after, any proportion in the form of a fraction, you can flip it around. What I usually like to do, if the problem is asking me to look for temperature, I put temperature on top. If the problem is asking me to look for volume, I put volume on top. And that saves me several steps on my calculations. And this law tells us that if I have a certain volume at a certain temperature, if I increase the temperature according to the kinetic molecular theory of gases, assuming this is a expandable container like a piston or a balloon, if I increase the temperature, the particles are going to move faster, which means they're going to hit the walls of the container harder, which means they're going to push it out. So as I increase the temperature, I should expect an increase on volume, which means this one is directly proportional. One increases, the other one increases. So when we put numbers into that, as soon as you get the answer, check the kinetic molecular theory of gases. Does your answer make sense? If it doesn't follow the kinetic molecular theory of gases, that means you did something wrong on your calculations. And always think about the balloon, and it will come easier to you. So let's work with these laws. What is the Boyle's law? I just told you that Boyle's law is P1 V1 equals P2 B2, where this is the before situation, and this will be the after situation. So given three variables, can you find the next one? And that's where the algebra comes into play. If I have a problem that is telling me that this is my pressure, this is my volume, if I change the pressure to this, what will be my volume? That means you have to solve for the new volume, which means I'm going to have to I'm going to have to leave the V2 by itself, and I do that by canceling this. Whatever I do on one side, I have to do on the other side. So since I just canceled that, I'm going to take it out. That way, V2 equals P1 V1 over P2, which is basically what we did on our first chapter when we practiced solving for x. So make sure you don't forget that. And this is when you look at the number that you get at the end and you said, does it make sense that I increased the pressure and the volume went up? And you said, no, that doesn't make any sense. So I did something wrong in the calculations. If I increase the volume, the pressure should go down. So always double check by analyzing and using logic with the kinetic molecular theory of gases. So that's what the Boyle's law is. So let's do a problem like this. And this is the way I like to do these problems. A sample of gas have an initial volume, so that's important. Initial volume 3.95. So I'm gonna say V1 equals 3.95 liters. So I'm done with that part. At a pressure, so initial, at the pressure of 705 millimeters of mercury. So P1 equals 705 millimeters of mercury. And remember, millimeters of mercury is a unit of pressure. And I'm done with that part. If the volume of gas is increased to 5.38, so the volume, the new volume, went to 5.38 liters. So I'm done with that part. What is the pressure? And it's talking about the new pressure. So I got everything I need. So the other thing I have to do, because this is the first problem we do, but at the end, we're going to have covered like 4 different or 5 different laws. So I had to figure out what law this one is talking about. And I already scratched out everything here. So the only thing I have is volume and pressure. So this has to be Boyle's law. And Boyle's law is P1 V1 equals P2 V2. I'm looking for P2, which means I have to leave P2 by itself. I'm going to do that by dividing by V2. That cancels P2. And whatever I do on one side, I have to do on the other side. Since I just canceled V2, let me get it out of there. And that's the formula I need to use. So let's use it. P1, 705 millimeters of mercury. Super, super important that whenever you're dealing with gas laws, always, and I'm gonna insist, always put the units, because if not, you're working blind. V1 is gonna be 3.95 liters. And I'm gonna divide it by V2, 5.38 liters. And that should give me my pressure. So I just, before I do anything else, I check my units. So liters cancel with liters. So the only thing I have remaining is this unit, which is a unit of pressure. So that means so far I'm doing everything right. The only unit remaining is what I'm looking for. So when I do that, I get that this is going to be 705 multiplied by 3.95 divided by 5.38. That's going to equals 518 millimeters of mercury. And before I do anything else, I'm going to make sure that numbers make sense. So my V1 was 395 and my V2 is 538. So my volume went up. So that means Boyle's law is inversely proportional. If the volume went up, my pressure should go down. And it went from 705 to 518. So that makes sense. It makes sense according to the Boyle law that it went that. What about the kinetic molecular theory of gases? Since my volume went up, now the walls of my container are farther away, which means it's going to take longer for the particles to hit the wall. So by the time they hit the wall, they're going to have less energy. So the pressure is going to be lower. Perfect. Everything makes sense. So now that you understand that, you can do your daily work with the Boyle's law. Once you do that, this is actually, this is not a mathematical problem. This you have to think. So by using the Boyle's law, you can explain that. Once you do that, then you can complete this table. So you're looking for P1 and you're looking for B1. For your own benefit, once you get those values, think about the kinetic molecular theory of gases and see if it makes sense or not. If it doesn't make sense to you, you probably did something wrong on your calculations. What about the next law, the charge law? We already said that charge law is going to relate temperature and volume, same as before and after situations. And according to the kinetic molecular theory of gases, the temperature is going to affect how fast the particles are moving. The faster they're moving, if the container is expandable, the more they will push the container outward, making it bigger. So that's how the temperature relates to the volume. Super, super important. Temperature. Whenever we're dealing with gases, temperature has to be in Kelvin. If you use degrees Celsius or if you use Fahrenheit, your result is going to be wrong. And the reason is Kelvin is the only scale that goes from whatever to 0, and that's it. You don't get negatives on Kelvin, so it's totally proportional. And that's what these laws are based on proportionality. So it has to be Kelvin because it's the only scale that doesn't go past 0. So let's use Charles' law. A sample of a gas has an initial volume, so once more, B1 equals 3.95 liters. And a temperature, obviously the initial temperature of 25 degrees Celsius. Immediately you said, oh, I'm dealing with gas laws, so this has to be Kelvin. So this is going to be 298 Kelvin, 25 plus 273 degrees. And it also tells me what temperature, so it's asking for temperature. So T2 is what I'm looking for. It's required for the volume of the gas to increase to 538. So the volume of the gas, the new volume, is going to be 5.38. And before you go any further, you can say the volume is increasing. Charles' law is directly proportional. So if the volume increases, that means that my temperature has to increase. So we know that our result has to be bigger than 298 Kelvin. And if we use the kinetic molecular theory of gases, if the volume increases, it's because the particles are pushing it harder and moving it outward. And for the particles to push harder, that means they need more energy, so the temperature is going to make them move faster, which increases the kinetic energy. So all that makes sense. So now let's see the math. So Charles, I'm looking for temperature. So I'm going to put temperature on top. T1, B1 equals T2, B2. Since I'm looking for temperature, I have to get rid of, since I'm looking for T2, I'm going to have to get rid of my V2, and I'm going to do that by putting it on top. That way it cancels. Whatever I do on one side, I have to do on the other side. So my new formula, once this cancels, my new formula is going to be V2 T1 over V1 equals T2. So let's do that. I got my values, right? V1, 3.95 liters. T1, 298 Kelvin. Remember, it has to be Kelvin. Divided by V1, which is 5.38 liters. Before I go any further, I look at my units. Liters cancel with liters. So the only unit remaining is going to be Kelvin, which is good because I'm looking for temperature, right? And when I put that into my calculator, remember, the temperature has to be bigger than 298 for this to be true. So 3.95 multiplied by 298 divided by 5.38 equals 219 Kelvin, which means the temperature went down. So I did something wrong. So let's look at this again. V1 is 395, V2 is 538. If I start 298, since the volume is going up, the temperature had to go up. So I did something wrong. Let's do this again. And there's no change because this is an excellent opportunity to show you why it's so important that you analyze the temperature at the result at the end. So let's do this again. So V1 is 395, no problem there. T1 25, which is 298 Kelvin. What temperature is required? T2 for the volume of the gas to increase to 538. So the volume is definitely going up, which means my temperature had to go up. So my temperature is going to have to be over 298. So my initial analysis is right. So I did something wrong with the formula. So I'm looking for the temperature. So I'm going to put the temperature on top. T1 over V1 equals T2 over V2, which means to get rid of the V2, I'm going to multiply by V2 on top, and I'm going to multiply by V2 on top also. That means this cancels, which means it's going to go disappear. So I don't think I did that wrong. So it gotta be that I put the numbers wrong. So B2 is 538. Yeah, I believe I put my volumes backwards. T1 is 298. And V1 is 395. When I do that, my liters are gonna cancel with my liters. And my temperature should be, let's see, 5.38 times 298 divided by 3.95 equals 406 Kelvin. 406 is bigger than 298, so that makes sense. So I'm so glad this happens. This shows you how important it is that you analyze these results against the theory before you proceed. I did everything right except I put the numbers on the wrong place. If I have continued like that without thinking about it, I would have got the problem wrong. So super important to always check yourself. And now you're ready to use Boyle laws to do this problem. Actually, to answer this problem using the logic that we just talked about. And once you do that, Actually, you know what? Let me do something here. That shouldn't be Boyle's law. That's Charles' law. Sorry for that typo. So using, according to Charles' law, solve this problem. And once you do that, you should be able to do this problem using Charles' law. And make sure that you check for that the answer makes sense. And once you do that, you should have a pretty good understanding of the Boyle's law. P1, B1 equals P2, B2. And remember, all these formulas are going to be on your packet, so you don't have to memorize them. The more you use it, the least you have to use your packet, so you can work faster. And Charles' law, T1 over B1 equals T2 over B2. But remember, if the formula looks like a fraction, you can flip it upside down. Always put on top the one you're looking for. And with that, we're done with this part of the lecture. When we come back, we're going to talk about Avogadro's law and the combined gas law. So that would be 4 that we would have down at that moment. So until the next time, see you soon.